Hello, I'm Samuel Archibald, student founder of Stunt, and today I'm going to be showing you this program. This program I just pre-wrote. It's very basic program, so let's just get started. What this does is it makes it so the serial monitor can, instead of giving you a value, it just tells you if it's up, down, left, right, etc., and it tells you if the button is pressed. So let's go ahead. I'm also going to show you some people were struggling with the theory of integers in the Arduino code. So I'm going to give you a really good analogy for it. I like to call it the box analogy. The box analogy is just saying, okay, when you're creating these integers, so you have just a normal integer, it's creating a box. You just made a box. The box is open, and you just created a piece of paper in there that's a 0. Then constant integer pin equals 2 is saying that you just made a box. You wrote the number 2 on a piece of paper. You put it inside the box. You took the box, you closed it, and you taped it over. And then you wrote the number 2 on the box so you can remember what it is. So now, whenever the program cannot go ahead and they cannot open the box and they cannot change the value that's inside the box. So if we go here, void setup, serial.begin 9600. So start communicating with the computer at 9,600 bits in a second. Now, this is another thing I wanted to show you is how to turn on the pull-up resistor. So pin mode, pin input. So that's saying, okay, turn pin, which remember, the box is closed, but we know that the number inside is number 2. So pin 2 is an input. Then it's an input, but digital write pin 2 high. Make it so that it's turning on the internal pull-up resistor. Which after I explain this code, I'm going to go ahead onto a piece of paper and I'm going to explain the potentiometer theory and a whole bunch of different stuff. And I'll explain the pull-up resistors. So void loop. X equals analog read A0. So what this is saying is read the value coming from A0, the pin A0, write it on a piece of paper, write whatever value, so it could be 512, write the value, whatever value you read onto the piece of paper, put it into the box X. So now now X is whatever number was just read. So this piece of paper is now invalid. You have a new piece of paper that it just read. And now Y is the same thing. Read value from A1, write it on a new piece of paper, put it in Y, and take out that 0. So the 0 is now invalid. Now it's a totally different number. So this is saying if the piece of paper that's X is less than 400, tell the computer to say left. If X is greater than, if the number on the X piece of paper is greater than 650, print right. If Y, if the piece of paper that's in the Y box is less than 400, print down. If Y is greater than 650, print up. So the difference between print ln and print is print ln, basically after it's done printing whatever number you put in here, it hits the enter key. It creates a new line, like I just did there accidentally. So, oh gosh darn it, there we go. So it just makes it hits that enter key, it goes to a new line like I just accidentally demonstrated. But if you just had a normal print, it would not hit that enter key after it, and it would just become one long line instead of new lines showing up. So if Y is we just went over that, but that's basically the print. That's explaining this part, all of that. If digital read pin, remember pin is 2. It cannot be changed, but it's 2. Is low. Serial.print button pressed. Tell the computer button pressed. Wait for 100 milliseconds. So I've already uploaded it. So open up the serial monitor. So we have up, down, left, right, button pressed. So that's the code. You go ahead and move around and it gives you the values, or it takes the values, puts it in those boxes, and it says, okay, if the value is this, then print a word. So that's just basically how the code works. I hope that box theory really helps, but now we're going to go ahead and switch over to the piece of paper, and I'm going to show you that theory. So what I really wanted to show you was this if digital read with the pull-ups, so that then you can go ahead and you can add extra functionality. So if you want a horn, or you want to turn on a light using this joystick, you can just use that button on there. That's it. It's embedded inside of the joystick, and so it makes it so the button, so you can add this extra functionality. You have an on-off state. And one thing I want to, I'll explain that on the piece of paper, the term floating. All right, so let's go ahead. I'm going to switch over to the piece of paper, and yeah. Alright, so I was going to go over to a literal piece of paper, but I was having camera issues and all sorts of stuff I'm going to go figure out in a second. But so I'm going into my CAD software. So this is where I design my schematics and circuit boards. So we can demonstrate it in here. If we go, I could demonstrate the concept of resistors and such. It takes a while to load just for the first time. Alright, so let's go to pot. There should be. It's close. Let's see here. We are looking for a potentiometer. You know what? That symbol will work. We are just looking for the symbol, aren't we? So we can just do this. Alright, so this is the symbol for the potentiometer. Usually, you don't actually see that small arrow right there means that there's a button associated with it. When we're talking about the joystick, we're actually not going to talk about that really small part. But when we use this thing, and we have one that way, one that way, we go here, 5-volt supply. And we have a ground supply. Alright, so now whenever you use the joystick, this is like when the joystick's in a neutral area. The arrow is right dead center on the resistor. Because a resistor resists current or resists electricity. You use it for passing through, but a potentiometer or a variable resistor makes it so you can move around this arrow on the symbol and it will change the resistance used and it'll change the voltage coming out of the right here. So basically this divides the voltage between 5 volts and ground whenever this arrow is moved. So if you move it all the way over to the 5 volt side, it'll read 5 volts. That's like if you move the joystick all the way to the right. And if you move all the way to the left, it'll go to ground. I believe it's right and left. I'm not sure. Just giving an example. But when it's when it's neutral, it's center, it'll read 2.5 volts. So when that is right there, this actually reads 2.5 volts. There, and you can go through all the math and you can tell like if this arrow is between 5 and half, what the voltage will be. But basically when it moves around, it changes the voltage. That's pretty simple. So it's just when it moves around, it changes the voltage, it divides it between ground and 5 volts. So a theory of pull-up resistors would be if we take a if we go get a resistor here. And we just go to, we don't want it passive, we want, it would work for our uses, but I want something that, there we go, that's close enough. Alright, here we go. So if we create the button circuit, so inside of the joystick, there's a button. So this right here is a symbol for a button. This is the symbol for a resistor. We go ahead and we do this. So basically this is the circuit. We have the switch and the resistor connected. Then we have that line actually going out to the Arduino. I'm not going to go ahead and grab a signal pin, but that would be the pin for the Arduino. Then we'll have a ground going there, and 5 volts right there. So this is the circuit that we created with the pull-up resistor and the button. So this button is inside of the joystick. You can actually see it if you look along the edges of the joystick. And whenever it's pressed, it goes to ground. So this would be pin 2. And so whenever this button's pressed, it goes to ground. But you have this circuit right here, and usually these resistors are about 10K. But when we enabled that pull-up resistor, we made it so the transistors arranged just so that there is a resistor between this line and 5 volts. Electricity is lazy, and it will go down whichever path has the least amount of resistance. So if you have a signal, whenever you press this button, the button will always have less resistance than a 10K resistor, which is what's usually used. So it'll go through to ground, but when it's not pressed, then the path of least resistance is this resistor, so it'll actually go through the resistor, and you get the 5 volts as opposed to the ground. When it's pressed, you get the ground. which unpressed, the resistance is actually, it's not connected, so the resistance is less to go up the resistor. Now, one of the things I just want to point out is they tell you that there is either high or low, on, off, 1, 0. There's only 2 states of digital. There's actually a third, well, there's kind of questionably a third state. That third state is called floating, which means it's not connected to either 5 volts or ground. For this circuit to work, we need to either be ground or 5 volts. It cannot be floating, otherwise the microcontroller will have a really hard time with it. So that is basically the pull-up resistor. And then the ADC, I'll just kind of show you the symbol, because it's really hard to explain. Just explain it. I'll try to find something. If I find something in the video description about ADCs that I like, and I go on like YouTube and try to find something that works well, that explains it really well. So let's see if we have. Nah, there's no good symbol. So so basically you have a pin and the analog signal. So whatever voltage you have goes in, and then depending on what that voltage is, there's 10 outputs in the Arduino. Hence the 1024, because there's binary math and all that. But so it'll go ahead and it'll turn certain pins on depending on the voltage, and that's how the Arduino is able to determine what the voltage is. So that is just a bit of resistor theory that I wanted to cover. That is, sort of the ADC. If I can find a video that explains it really well, I'll put it in the video description. But thank you guys for watching this done video. Like if you dislike, like if you like. Hit the thumbs down if you disliked it. Subscribe if you're in the workshop, or if you want to see more electronics videos that are related to the workshop. And as always, thank you. Go to www.stuntech.org for the website. We have a Facebook page. And yeah, see you guys.